problem 14.3.14. We don't have a story in this particular problem. What we are given is a set of ordered pairs. There's 5 ordered pairs here. It's x's and y's. And also given a partial ANOVA table here. And I've copied this information over into the Excel file on the right, and really just getting the sum of squares information from there, because with that information we can actually calculate the coefficient of determination pretty easily. Recall that the coefficient of determination is just the sum of squares regression figure divided by the sum of squares total figure. So this is what explains the variation in the dependent variable that is explained by the independent variable. So in this case, 84.3%. So with that one, we can do pretty easy because of the information we were given ahead of time. And the next question asks about the null and its alternative hypotheses. So with this hypothesis test, what we are testing for is if the coefficient of determination of the population is greater than 0 based on our sample data. So if it is greater than 0, that means that at least some of the variation of the dependent variable is explained by our independent variable. If the result was that the determination, or is that the coefficient of determination is less than or equal to 0, then that would mean that there would be essentially no variation, or nothing would be explained by our independent variable. So moving on from there, we are calculating our critical f-score, and with that we just use an Excel function, which is the f.inv.rt. And recall that our probability for this function is just our alpha, 0.05, and our degrees of freedom are in here. 1 refers to d sub 1, so we are using, of course, the F distribution. Recall from our ANOVA chapter that the F distribution has 2 different types of degrees of freedom. For our regression tests, the d sub 1 degree of freedom is just the number of independent variables, in this case 1 is the simple regression, and the d sub 2 degree of freedom figure is the number of ordered pairs minus 2. So the number of ordered pairs, again, is 5. We have 5 sets of x's and y's, and subtract 2, that would give us 3. So that gives our critical f-score, 10.128, and then we calculate our f-test statistic, and in this case we use a formula from the chapter, regression chapter, and this one isn't really all that difficult. It's just stating, if I highlight it here for you, that in our numerator of the formula is the sum of squares regression figure, so that's this one here, 31.347. In the denominator of the formula, it's kind of 2 parts. We have the sum of squares error figure, in this case 5.83, that's here, and we divide that by the number of ordered pairs, which again is 5, minus 2. So that's why you see the C11 here refers to the number of ordered pairs, and just minus 2, that's just a direct input there. So that's how we get the f-test statistic, and to interpret our results, do a couple different ways. It did not ask for the p-value, but if we determine it based on the f statistic versus the critical f-score, the f statistic is greater than the critical score, so that puts us up in the rejection area. Again, recall that the f distribution is a skewed right one upper tail distribution. So in this case, our f-test statistic lies in the rejection area, so we would reject the null hypothesis in this case, and we would state that there does appear to be a relationship between the x variable and the y variable. Could have also calculated a p-value using the f.dist.rt function, and with this we use as our x is the f-test statistic, and then we use our degrees of freedom. Go ahead and just put some cell references there. So with this, our p-value is also less than alpha, meaning that we come to the same conclusion that we would reject the null. So I want to move on from here and show you how to get the output in the data analysis Toolpak as well as XLStat. So I'm going to go to data analysis and let's run a regression here. Let's go back this out. So we want it to put our Y range here. It's going to include the label. X information here. Labels is already selected. Confidence level is already at 95. We need to adjust that. And we have our output here. Find kind of a good place to put this. Set it right here. Actually, I need to come up a little bit. Let's see what we come up with here. All right, so in this case, we can see that our coefficient of determination is the same, 8.43, and our R squared here, 8.43, rounded as well. I'm just going to highlight that. And we aren't necessarily asked for much from the table other than just kind of the two main items, which would be the R squared coefficient of determination along with the F score for the model. So this is our F test statistic here, and this again is what just tells us that the overall model itself is significant. And you can see that here with a p-value of 0.027, which is what we calculated down here as well. And looking at that independent variable x, of course that's going to match the p-value of the overall model since there's only one independent variable. This figure will be different if we have multiple variables, and what these do down here in this table is to explain or help us determine whether or not the independent variable itself in the model is significant. So when we do multiple regression and we have more than one independent variable, we'll be able to see which independent variables are significant in the model and actually contributing to the overall F statistic and R squared figures. Now, I'll show you real quick how we can do the same thing in XLStat through modeling data and linear regression. Let's see, this is our Y variable here. Okay, and our X variable. And we have the output going on a separate sheet. We have confidence interval of 95. And just make sure that our output is just the ANOVA table and that there are no charts. I'm not going to use any charts right now. And with XLStat, we are coming to the same conclusions. You can see that the R squared coefficient of determination is 0.843 again. And you can see our F statistic down here at 16.067 as well.